On calculating potential due to a continuous charge distribution by using multipole expansion, I am considering this third configuration, in which lambda is given by, that is charge distribution, linear charge distribution is given by lambda is equal to k cos of pi z divided by a. For this, first I am going to calculate monopole moment. Q is equal to summation over k into cos pi z divided by a between the limits minus a2 plus a dz. That is equal to k into integration of cos theta is sin pi z divided by a into a divided by pi between the limits minus a2 plus a. This term will vanish. So monopole moment in third case is 0. Next I am going for dipole moment. P is equal to, what is the expression for dipole moment? That is second integral z lambda dz. So k into summation over minus a2 plus a z into lambda cos pi z divided by a dz. Okay. So again here we need to use UV formula by taking u is equal to z and v dash is equal to cos pi z divided by a. So through this, what is the value of v that we're gonna get? A divided by pi into sine of pi z divided by a. This I'm going to use for calculating this. So first I'm calculating this integral. So the standard formula is integral over u v dash is equal to uv minus integral over v u dash. In this I'm going to substitute this. That is equal to u is how much? Z into v is how much? A divided by pi into a divided by pi into sine of pi z by a, sine of pi z divided by a between the limits minus a2 plus a minus summation over v is equal to how much we got? A divided by pi, I am writing outside the integral, into v is sine pi z divided by a into u dash is dz only between the limits minus a2 plus a. That is equal to, anyhow when you substitute z is equal to a gets sine pi, this term will vanish. Only we need to calculate this term minus a divided by pi, and this also over a complete cycle sine theta value also 0 only. So if you want to calculate, you can calculate. Integration of sine is minus cos, so minus into minus plus a divided by pi into integration of sine is cos pi z divided by a between the limits minus a2 plus a, that is equal to a square divided by pi into cos z is equal to a, cos pi is minus 1 minus cos of minus theta is cos theta only, cos pi again is, it is minus 1 minus into minus plus 1 and minus 1 altogether is 0. So in this third case monopole moment is 0. Of course the dipole moment also, P also 0. Then we should go for the next pole, that is quadrupole moment. In this integral, quadrupole moment is obtained by substituting n is equal to 2. That implies I2 is equal to what you're going to get? Summation over g square into lambda dz. And I'm going to calculate here. So I'm going for the third term. What is the third time? Quadrupole moment, I2. That is summation over z square into, what is lambda? K into cos pi z by a dz between the limits minus a2 plus a. So to carry out this process, again I should repeatedly apply this technique, this formula only. That is equal to k into, first I should write down u into v. Here u is z square Here u is z square and v dash is cos pi z divided by, we should use over here. So u into v, u is how much? Z square into v is how much? V. Integration of this is a divided by pi into sine pi z divided by a, between the limits minus a2 plus a. Next, minus v into u dash. What is v here? v is this only, a divided by pi into summation over sine pi z divided by v into u dash. U is z square. U dash will be how much? 2z dz. Between the limits minus a2 plus a. That is equal to, anyhow this integral will vanish because a, if you substitute here, a gets sine pi value is 0. This term vanishes. Now I should focus on this term only. Minus 2a divided by pi. 2a divided by pi into summation over minus a2 plus a. I should go for this integral. Z into sine pi z divided by a dz. Now I should calculate this integral. Same as I proceed over here. Here it is called, this is sine theta. Okay. So for this purpose, that is equal to minus 2a divided by pi. You put it aside, and this k also I forgot to put over here. You should include k into uv formula again. Here u is z, v dash is sine theta. So u into v, u is how much? Z into v is how much? A divided by pi into minus a divided by pi into cos of pi z divided by a. Okay, between the limits minus a2 plus a. Next, minus vu dash. So minus plus a divided by pi into summation over minus a to a cos pi z divided by a dz. So if we carry out this integral, okay, what we're going to get here in this, if we carry out this integral cos, you will be getting again sine. Anyhow this integral will vanish. Only thing that is left over is this one. So therefore that is equal to, what you're going to get, minus 2a divided by pi into k into, what is left over here, a minus a by pi. I will write it outside, minus a divided by pi into, now substitute, z is equal to a into a gets cancelled, cos pi is minus 1, minus z is equal to minus a into cos of minus theta is cos theta only, so cos pi is again minus 1. That is equal to, how much you're going to get? Minus into minus plus a, plus into minus minus a, this total value is minus 2a. Okay, this into this, you will be getting minus 4a cube k divided by pi square we will be getting. Therefore this, what I calculated all through this, I2. What is I2 here? I2 is quadrupole moment I calculated. So therefore this I call it as generally Qij, quadrupole moment for this charge configuration is how much? Minus 4a cubed k divided by pi square. Through this I am going to calculate the potential. Therefore V as a function of potential is given by V is equal to, here I should substitute n is equal to 0. Anyhow that contribution is 0. Next, n is equal to 1. Dipole contribution also 0. Next I should substitute n is equal to 2. Then I will be getting this quadrupole moment term, because of which 1 divided by 4 pi epsilon naught into n is equal to how much? n 0, 1, 2. 2 plus 1 is how much? 3. 1 divided by 3 into, when n is equal to p2 of cos theta is how much? 1 by r cube into p2 of cos theta is how much? Third term on the in the Legendre polynomial is how much? 3 by 2 cos theta minus 1 divided by 2 into Qij value, how much we got? Minus 4a cube k divided by pi square. So if you write it over here, that is equal to how much we're going to get altogether? Potential due to quadrupole moment as a function of r is given by minus 4a cube k divided by 4 pi into pi square, pi cube epsilon naught r cube into 3 cos theta minus 1 divided by 2. This is the expression for potential due to this configuration. Of course, we can go for higher order terms also, but octupole moment contribution when compared with this quadrupole moment is negligible, because of which I am not going for higher order terms. This is how, depending on the charge configuration, we edited this integral and we calculated the potential leading terms in the potential.